So this lecture will be in English. Thank you all for joining us today on this great event that is organized by Code Value. And in our presentation now, we'll try to show you what are the key components that we consider and that we analyze based on our experience working with startups, providing offshore services to startups and as well as enterprise companies. We'll try to show you with a few real case studies how we choose the right architecture when we build our projects and when we provide our services. But first, a little bit about me. So my name is Ivo, and I'm the CEO of Code Value Bulgaria. That is responsible for offshore activities of Code Value. And I have more than 16 years experience as a Java developer. I'm coming from a technical background. And this is the added value that I bring to the team, is that I'm a very technical guy and I try to be involved in all the projects, not only in administrative way, but also in the technical aspect. And I'm very passionate about technology and about architectures. And for the last 9 years, I'm managing offshore activities, offshore software development services. As I said, we work a lot with startups as well as big enterprise companies. And this is Sonia, who is the CTO of Code Value Bulgaria.
Hello from me, I'm Sonia. And how Ivo said, I'm CTO in the Code Value Bulgaria. I have about 18 years in the software development, taking part in many projects for Bulgarian administrative agency and banks. Started like a Java developer, and after that grow to technical team lead and project management. Now my position is related with all technical process operations in the company, and we are working very close with the team, especially when we should choose the right architecture. And shortly we'll talk about and we'll give some answers of some simple questions that we are asking during this process. We'll talk about the challenges that we are facing, about the architecture patterns that we are often choose, and all of this will be emphasized with some real projects in our work and in our company. And let's start with why it's so important to choose the right architecture. I think that the answer is simple, and this is because the right architecture impacts significantly the success and longevity of our project. Selecting the appropriate software architecture is the foundation for building one reliable, efficient, and secure system that can meet all future and current needs for the customers. The next question is when we make this choose for the architecture. This typically happened at the beginning of the early stages of the project, when we analyze all requirements, when we define the key components of the system and their dependencies to each other. But you know that the architecture is one-time decision. It's not one-time decision. The architecture is adapt and evolve during the whole project life cycle. What are the challenges that we met during this process? We tried to group them in some 4 sections. And the first one, this is the criteria. When we make the right decision, we need to have a clean goals and clean criteria for that. And this is possible when the whole team have a deep understanding for all functional and non-functional requirements, and as well effective communication with the customer and stakeholders. The next one, this is the knowledge or the know-how. Do we have the right expertise and experience to develop the chosen architecture? If no, do you have a time to make the investigation? Do we need to make a proof of concept? All of these questions are very important because for us, the right decision, this is the informed and consulted one. And you see that the technological landscape is developing so fast, and to keep up to the trends is very hard. But this can be achieved with continuous learning. And the knowledge always affects the time. The time is always crucial for the projects. Most of the projects have tight deadlines, that limited time for investigation, and we should find the balance between these time constraints and the time for development. How we achieve this? This is possible when we're using some strategies for this. When we prioritize the requirements and the goals that must be achieved, when we make a preliminary assessments for the chosen architecture, and as well that this architecture is constantly reviewing and adapting to the changes. And the last challenge, which is maybe it's not the last, this is the cost. Is our decision cost effective? We know that the projects always have budget limitations, and how it's important to how we achieve this to manage the budget limitation is when we make preliminary assessments of all cost implications, like not only the development efforts, but the all infrastructure and licensing cost, maintenance cost. This is a very important implication that we are taking apart. And the next one is which is the architecture patterns that we are choosing.
Yes, I'm sure that many of you know that there are a lot of different architectural patterns, so like monolith, like microservices, like client server, like event-driven. So which is actually the right one for your project and for your application? And as Sonia said, there are different key components and factors that has to be taken into consideration. And basically in the next case studies that we choose to present to you, we try to present what are the key factors that we analyze, that we take into consideration based on our more than 9 years experience offering software offshore software services to Israeli companies, from startups to enterprises, and to be able to explain to you how we choose the right one architecture based on the project. So the first case study that we wanted to present to you is a project called Find Air. It's a meta search platform that searches for flight tickets. It's an innovative platform, it's web-based, and it uses different sources like small providers like Skyscanner, Kiwi, as well as global distributed systems like Amadeus and Travelport. And using its proprietary algorithm in real time, it shows the best price for the given trip that the user wants. Basically, this project was built in 2017. The first phase of the project was built in 2017. We have several phases in the roadmap that we take into consideration when we choose the right architecture. So the main requirements for this, that it has to be a web-based platform. It has to integrate with different third-party providers that we have no control over their data. It has to use algorithms to achieve the best possible prices and asynchronous communication. And of course, it has to be fast and easy to work with so that it can present to the user the results right away and not in order not to lose the user. And of course, because it's a public system, it has to scale like indefinitely in order to support multiple requests from multiple users. So basically taking into consideration all these requirements and also the high integrity and the high operability and the scaling and also the isolation that has to have the different services, we decided, and the roadmap that I will mention in a few seconds, we decided to choose the microservices architecture and also to apply event-driven also in part of it, because the business model was all about data that we got from the different providers, and the communication was asynchronous. So basically the technologies that we use were Java, Spring Boot, Node.js, Socket.io, and Redis. We use Redis both for caching and for the event-driven architecture and communication. And basically we split the architecture into 4 major microservices. The one is handling the front end, one is handling the back end logic, and the search engine service is like the heaviest one that has to scale up and down depending on the load, and that it gets the data from the different providers and do some kind of a manipulation, run the algorithms. And then the 4th one is the socket service, the Socket.io service, and the Node.js service that gets the data that is received from the different providers and pass it back to the user. I mentioned about also the roadmap, that it's very important to take into consideration also the roadmap of the project when you choose the right architecture. For example, now we started, like last month, we started the 2nd phase of this project, which in the roadmap was to build like an affiliate API that will be built as a separate service that will communicate with all the rest, so that other meta searches like Skyscanner can integrate and get the results from our system and show on their website. So this choosing the microservice architecture allowed us to be able to add additional services without changing the logic of the other services or without interfering the work of the platform, which was very important because, as I said, this is a public platform that has to be available in order not to lose the users that are coming on the website. And in the next phase, we will also support machine learning that will manage all the data that we gathered in order to build different statistical models to be able to predict where the user is going to present him the cheapest prices for the different destinations, for the different dates, to predict the user behavior and so on. So this will be other microservices. We built this in AWS. Back then, Kubernetes was not that popular, so we used the auto-scaling group with EC2 instances. We have each service on a different scaling group. One was scaling in one way, the other was scaling in the other. We use load balancers. For this phase, as I said, we will add additional services and also do the improvements. We will add Kubernetes that will be able to manage easily the containers, to easily the services, better control over it, and better utilization of the system resources. And yeah, basically that's it for the project Finder. It's a very interesting project, and I think that it will grow a lot in the future. And the next project Sonia will present, the next case study.
Okay, the next case study. This project Tachi. This is a video streaming platform with additional shopping feature. The platform is like a mediator between the store owners that can able to promote and sell their products, and the video content producer who are able to achieve more interactions and watch time from the end users. The products, how you see on the clip, they are attached to the video shots. And when the user interacts with the video, they blow up and the user can watch them. The platform contains of 3 main components. One was the player that you see the video of his. The other one is the studio. This is the heart of the platform where all the configuration and management of the videos are done. And the third part, this is the marketplace, where all store owners can register and can define their products that can be used in the video project. We are working on this project more than 3 years, and it's in a final phase before production. At the first step, the first requirement for the project was to change the legacy code, which was a proof of concept project. It was a monolith, to change to a scalable platform. The other requirements that we have here is that we faces the many different functional components of this platform that can be work separately from each other independently. We have many objects of the projects who have a tree structure. The customer want to have a control over the video management and to change the configuration there. As well as they wanted to have a platform independency, not to rely on some special cloud platform with their services. Of course, like a performance and scalability. All of these face us that we choose the microservice architecture. This microservice architecture we realized with Java and Spring Boot for the backend services, React with the custom components for the front-end services, MySQL for database, and Neo4j, this is a graph database, where we store all these three structure of the object. All services are Dockerized. This allowed us to be independent from the platform. We use Kafka and Spark as well. This is for the process for gathering different events from the player, for the user events, and analyze them. This is for the statistic. And currently all of this is realized in the AWS with the Kubernetes cluster. How the architecture is looking now. All front-end services are located in the S3 buckets. They communicate with the Kubernetes cluster in the AWS, where all backend services are configured there. As well, the databases are there, the Kafka as well. In the like a repository, we are using GitLab with opportunities for automation CI and CID deployment in the cluster. We have one external service that we are communicating, and this is the payment provider, which is somehow isolated in one of the backend services. The marketplace backend services is only communicate with this. What we achieved independency of all functionality components that can be developed and expand independently from each other. We have a good performance, which is very important for the video streaming. And very easy scalability of the platform. And the next case study, we'll talk.
The last case study that we wanted to present to you is a project called SOVA. It's a project that one of the famous attorney companies in Bulgaria asked us to build for them, custom. And it's a platform for calculating remuneration of the lawyers, managing their contracts with the customers, managing their customers' database, and exporting timesheets and invoicing the clients, and calculating also the commissions and so on. Sorry, basically, The crucial part in this project was the time to market, which was like only 2 months. The project was supposed to be delivered and in production within 2 to 3 months. The system has to be internal one, meaning that it has to be deployed internally because it's about attorneys, so it's a very confidential data, so they are very strict on this one, which means that we'll have to do in-house deployment of the system. And because as you might think that they don't have the attorney companies, they don't have a huge IT department with programmers and etc. So we have to build it in a way that it's simple and easy to manage, simple to maintenance, and simple to deploy and support. And of course, this was an internal system that was not supposed to be used by more than, let's say, 30 to 50 users simultaneously. And taken into consideration all these 3 factors, we have chosen the monolith architecture for this one. It allowed us to build it very fast, to build it very reliable, and we use Java and Spring Boot for the backend side, and JSF with prime faces to serve the front-end pages, and MySQL for the database. And basically everything was running in an on-site Linux server that was on client's premises. It was very easy to deploy, no AWS, no Kubernetes, no overcomplicated stuff. And basically the architecture was very straightforward. So we have the, as I said, we have the JSF for the front end, we have the services in Java and Spring Boot, repositories and the utility classes and the MySQL database. And basically we were able to achieve very quick development on this one, very easy to support and maintenance even by their IT, which was not that big, their IT division I mean. And we were able to achieve a stable system that was able to be used by many users simultaneously. And this specific example was to show you that it doesn't have to be, you don't need to overcomplicate things. You need to always choose the right architecture for the project based on the customer requirements, the project goals, and the roadmap. So if we have to summarize what we tell you so far, I want to emphasize that I know that nowadays it's very popular to just, look at Stack Overflow or ask ChatGPT and to tell you which is the best architecture, but don't try to overcomplicate things or don't use things that are just because they are trendy now or modern. Always look at the specific needs of the project, of the specific requirements of the customer, of the specific roadmap and project goals. Of course, cost and budget is very crucial as well, because you don't want your client to burn out his budget just for the infrastructure. Don't overcomplicate things that are not needed, and take into consideration also the time for development. And basically, I think that covers what we wanted to tell you guys. So if you have any questions, please ask. If not, thank you for your attention.
Thank you.